Welcome to another video at Indies Tech. So in this video, again, this is a update video, but the important thing is that in this video, I will show you some important modification. This same time will be another VREP robot simulation and Fusion 360-degree part design tutorial as well. This, I think, will be a two-part session. So I will try to make each part under 10 minutes. Now, without further ado, let's get started. Now, as you can see, this is the robot. Many of you who are following me know that I was working on this project, and so the important modification I got is that I got Omni wheel, then robotic arm is attached, to power source, and with a Raspberry Pi 4 computer, not the 5 one, Raspberry Pi 4. So at the moment, in current condition, this is fully sufficient in terms of power. It can be controlled via laptop, given the fact that you connect it with a VNC player to your Raspberry Pi 4. Now, the challenges I faced with this project is that with all the hardware, I needed more space. But with my standard Arduino Buggy, this Perplex Arduino Buggy, there is very little space. So what I did is I did some important modification. I added some part and made some bit of extra room. Now let's get started. Now this is the VRAP scene I have created for the robot simulation, also to demonstrate my modification for this video. Now this part you will see how to import part from Fusion 360 to VRAP CoppeliaSim software. So this is the environment I have previously made. You can see my previous video, which I will put in the link description. Now as you can see, I have just copied these two cars. This is just like same part. So what I'll do is I will do the modification. I will import the Fusion 360 part and I will integrate with this project. In this way you'll be able to see my modification, and you will also get some experience how to import part from Fusion 360 to VREP CoppeliaSim. So this is changed. This is the copy. I'm not going to touch this one, but this one I will modify, and the essential modification before that, what it is, that as you can see, it is just a group of important STL part. What I can do is I have to break this group. So what I do is that just right click, edit, then ungroup. So as you can see, if I have ungrouped and it has got all the parts, they are not connected each other. First I will move this top bit, the top base plate. The top base plate itself is another group. As you can see, they are connected together. So what I will do is I will make them explode as well. So again, edit and ungrouping, ungrouped. So this is now totally ungrouped. I will for this one I will move the top plate so you can see the internal electronics. So I have moved the top plate, and then the what I call is the pi pack. So this is the essential of this project, is that this has got this buck converter and motor controller, Raspberry Pi 4, and a massive NIMH battery pack and the webcam. This is a primitive shape. This is for purely for simulation purpose. What I will do is I will make it disappear. I will make it hidden. The way you do make it hidden is that you select the part, then you go to the layer at the corner, and from the layer you assign the part in different visibility layer. No, sorry, just first you need to edit this part. So if you double click, so this is a cuboid, as you can see, this one is there in cuboid. If you just double click, then go to common, and you can see this visibility layer 1. What I will make it, I will make it visibility layer 8. So this is visibility layer 8. Now if I go to layer in general and turn off layer 8, the part will disappear. So but the part is already there, but it's invisible. This part I will delete this four wheel because I'm going to replace them with the Omni wheel like the original project. As you can see, the original project has got Omni wheel rather than its normal wheel. So let's do it. So if I just select this part, shift, select four of the part, but you need to be careful because I can see this number four part, number four wheel is already grouped with the base plate, so I would not touch that one. I will leave that one, or I might just edit and explode, ungroup the whole thingy. So the whole thing is now ungrouped, and I just delete the wheel now. But the way the will work is that the robot simulation can't take the STL file. It only work with the primitive shape like a cylinder or cuboid. So underneath the wheel there is like a primitive shape which I'm going to make invisible in this stage. The way you make it invisible is that you select them all. I'm deleting at this stage, so they are deleted. Now I have already made the modification of the base plate, but for now let's import the base plate first. So for importing you just go to file, import mesh, then my files are already ready in the download. So Basecamp STL. The scaling I'll make it 0.25. This is from the previous experience. The imported part was extremely large, so I'm just making 0.25 and import. Now I don't see my part, so this is the part. If I just click the part and go to this fit to view, this will show my part. Now then I will zoom it out. So the part itself look like extremely large. I'm going to import it again. For some reason it was not working, so import mesh. So the file I have already created in from Fusion 360, then I have imported to .stl, and I will show you in a minute how to convert a Fusion 360 file to .stl format. And as you can see that VREP only recognize few of the format, which is obj, gxf, ply, .stl or DAE. Without this format, any other format will not be accepted, like STEP. So base plate, open. I'm not going to do any modification, just import. As you can see, the part is extremely big. What I will do first is that I will scale it down. So the way you scale it down is that you do double click on the part, then common. Here you can see the scaling factor. So first I would choose in place scaling, then 1/4 of the part, which is like 0.25 scale. I think this is the part. What I will do is that the part is already selected and I just press the fit to view. So the part you can see here, it is still, I think it's still bigger, you know. Let's first move the part, how it fare against the existing robot buggy. So the part is already selected and press this move button, then you will be able to move it across. So it's near the buggy now. So what I will do is I select the buggy and make it fit to view. So this is the buggy, then I will zoom out. Right, so this is our part, and let's move it further close to the actual buggy. Okay, so this is the part here, and scale it down to further 1/4 or maybe 0.5 this case. So just click scaling and 0.5. Okay, so part look like getting similar. If I just see the view to view it again, from the top. Okay, so it looked like it need to be further scaled down. I'm going to scale it to 0.9, which is like 90% of what you got the size now at the moment. So as you can see, it has reduced a bit, but not fully. But let's see if I move it to the right place, how it fare. Before that, I need to change the orientation of the part. So to change the orientation of the part, this is the button for changing orientation. Then which orientation? I probably want to orient it number well, Y orientation. No, Y is not the perfect, as you can see. If you go to the mouse orientation and you select the part, then you choose the orientation and you can see that is like a turn wheel. Here you can see there is a turn wheel which shows the direction. I think this is the Z orientation. This a bit is like a trial and error. Yes, this is Z orientation. Then it goes to its central location. How is it fair? At this stage, it looks visually in same orientation. Let's just move it. So the part is already selected. So for the move button, this is the button at the top. So you click the move button and go further close. In this stage, you probably have some idea how my new modification would look like. Now to move the part more fine detail, so I will go to the translation, not mouse translation. This time it will be the coordinate translation. So if all the buttons are off, like X, Y, Z direction are off, only X is on. So if I go +1, how does it look like? No, my part just disappeared. So that's not the direction I want. So Control Z, get the part back to its right position. Then try again with 0.5 in Y direction. That disappeared as well. That's not what I want. I want. So the way it works is that you can get back to its previous position. Just press minus or opposite sign. So if I press +Y, the part came back. Same I will do for the Z, 0.5. Okay, so it's all disappearing. I don't know what is happening. I can get the part back by just doing -5. Okay, so this time I will go like granular. So 0.00. How about I just check my mouse rotation? Okay, so it's in X and Y axis. Let's just do X. Okay, so if I just go 1 in X axis, as you can see, the part is moving, but I need to align it. I need to align it with this line. So because this motor is gonna move to this bracket. Let's zoom in further for more good understanding. I'm going to color the part, so I'm again selecting the part. The part is here. So if I select it and double click, double click here. Here is the option for color. I will get it pure red. So ambient diffuse component and pure red. I will turn off the green and blue channel of the color. So this is pure red now. Let's see the part from the top. VRAP has serious problem with the viewing angle. It's not like Fusion 360, like top view, bottom view, and plan view. There is only few options for the viewing. These are the three options. So you need to manipulate them to get the perfect view. So I'm choosing the part again. I'm going to move it in the X direction. So this stage, it look like it has come to the right place. As you can see, it is increasing the volume. Also, you can see the clamping mechanism of two of the plus sign. Let's go more closer. Okay, so as you can see, this two plus sign plus clamp, it will go inside. There's like a bracket hole, which is more, I can show you physical board for understanding. As you can see, this is part. This is the plus sign. You want to see, and this plus sign will go. This is the part. So I will get the part up again in Z direction. I will be really careful this time. 0.001 Z translation. As you can see, to click so many times before just raising to each slot. Fit to the view. So how is it faring against the physical location? Okay, so it's not properly slotted, so I need to get it more this direction. Again, move. First select the part, move, then I think this is more Y direction. So if I click, no, it's gone again. The value was extremely high, so I just go 001. Oh, I need to go back fast. So I need to go to the plus direction, Y translate, too much, minus, then fine tune and just reduce the value to 1 and pass this time. So Y translate. Okay, it look like this is almost slotted, but it is still a bit oversized. But for the sake of simulation, I would just skip this part. I would leave this part as the size is displaying, but in reality it is perfectly slotted. As you can see from the robot, is difficult to show. It's like perfectly slotted, this part. So you need to try different size and location ratio before it fits to the existing .stl. There is no like a snapping option like Fusion 360 or Inventor, Autodesk Inventor software. So basically this is the plus slot. I want to put it in this plus blank slot. The way I would like nearly achieve it is that just trying different location what works best. As you can see, this plus is slotting perfectly, but this one is slightly angular, so that means the plate itself is a little bit oversized than the existing .stl plate itself. I think at the moment I'm not too concerned about that, just which is like near perfection. I don't want to be 100% perfect, it's just only for the visualization. Now I will copy this part, copy this base plate for this side as well. So if I just control C, then control V. Now the part is already there, so you need to move it. I'm just moving it with the hand, so it just copied, just overlap on on top of the same part. Now the orientation is a problem, so this part need to be different orientation. So what I will do is I will just use my like rough orientation. Again, this part is another trial and error based scenario. So as you can see, I'm just rotating it blankly. I just want to be like a near perfect with, but then you can do more like a granular fine detail rotation in this way. But let's see. So first one is rotation in on frame in z-axis. So if I just go to the rotation in z-axis with on frame, then maybe point 1 degree at a time. So 0.1 degree is getting different way, about getting different way. So this part looking like it's getting parallel. So I'm happy with whatever the location at the moment, just get the position this time. So this is the rotation, object, item rotation and orientation but tab. Now I'll go to the translation tab. So same like last time, I will just go to +1, see if it's working. No, it's basically getting up. So I'll go to the minus tab just to get back where it come from. Can't remember it. I think it was X direction. Yes. Nearly perfect aligning. It will be zoom. So this is the situation now at the moment. Select again, doing some more fine detail movement in Y direction because this plus need to be slotted in this blank part. Almost. So I should not go too much fine detail on that case. This can ruin the whole thing. Just go minus. Just want to make sure these two sides align each other. So now currently our part look like this. Okay. I think in terms of Z or Z location, the part need to be moved a little bit up. So I will just select both the part. Select one at a time. Then with the fine orientation plus Z orientation. Just to see how it is faring. This one need to go a little up. So again, plus Z orientation. This is enough. very unplanned fashion, this video is getting longer, but I hope you guys don't mind it. So what I will do is I will hurry up and I will show how to convert Fusion 360 part to STL and then import it to CoppeliaSim. So I'm getting my Fusion 360 on. So this is the base plate you can see I have designed in Fusion 360. Now you need to import it to .stl format or one of the other format which CoppeliaSim accepts. So to import it, just export it to the .stl format. So .stl format. So at the moment it will export in .f3d. If you go to drop down list, here you go, you see .stl format. So this is exported to .stl format, but make sure that you got your internet connection on for this modification. I think because the Fusion conversion engine works a bit of like remote processing. So part is complete here, as you can see. .stl format, Arduino buggy modification.stl format is showing file for shown Explorer. So here you can see the .stl format. Arduino buggy has been created. Now go to CoppeliaSim back again, then file, import mesh, and here you can see our file. Open it, then again the scaling factor is asking for that whether I want to modify any of the scaling, but I would recommend not to do anything. Then import. So it has been imported, but I don't see it. To find it, you just zoom out. You can see very large part has been imported. Then you scale back. I've already shown you how to scale back, but just for the sake of this part, you just go to auto scaling, in place scaling, always in place scaling, then 0.5. So it has been resized down to 0.5 scaling, but you need to do further scaling to satisfy this. To compare this with the existing model, you need to move it closer to the existing model, then you have a better view, then fit to view skin. So this is the scaling factor now at the moment. Again, go to 0.5 factor, scaling factor, and more before it is fit all the way to the existing .stl file. Now ungroup these TG motors and just move them to the bracket. So you select them and move them manually one by one. So as you can see, I got more higher volume for keeping my parts there, more spaces there. Then again, another group of parts I have already imported. As you can see, there are the motor clamps, but they are still oversized, so I have to edit them. So what I will do is first I will they are joined together because that's how I 3D printed them. Again, I will get my physical. So this part of link, you can see the 3D printed clamp, the white clamp here. This is the clamp, as you can see. So I have to divide them first. Edit, select the part, then edit, then grouping. As you can see, there's only divide option, so they are divided now. And what it means is that now I can individually move them different locations. And I will make it fit for this surface, but before that I need to locate them in the right location just to get some idea about the scaling factor. So the best way to make the job easier is that first use the mouse translation for like the mouse translation is not very perfect. I need to go to z-axis, so you select the z-axis and go down, then x-axis, go in. Every time you need to follow the global orientation where the location of the part is, then just move a bit anytime at a time. And granular detail, you can go in the translation, location translation I mean. Now I need to resize the part. I will just delete this. Scaling, in place scaling, 0.9. That looks more befitting. So this bracket need to go in this slot. This is Y direction. How does it look from the top? Need to move a bit in X direction, plus X. That looks more perfect. Now you need to slot it the motor hole. So as you can see at the moment it's not perfectly slotted. This, I mean these screw holes. Minus. Okay, that looks much better. Not perfect, but near perfect. Then I can just slot this screw to this hole. Now I will copy and paste three more for the three other motor. So the part is already selected. I have changed the name. So motor clamp. I'll just copy object, then Ctrl V, then move to Y direction, plus Y. Now the parts are perfectly created. The dimension is there is slight discrepancies in dimension, but there is no discrepancies in the actual 3D file, which I will include in the comment description. You can download this .stl and Fusion 360 3D files, and you can build this part yourself. What I will do is now I will move this screw across just to bolt them as the real screw would. This is the beauty of CoppeliaSim, that you can do so many things which otherwise you would not be able to do in this more visually pleasing way. I will delete this part now, select all of them, no, one by one. Some of the part can So this video is getting quite long, so I don't want to waste any more time, but here you can see the final assembly. I just did all the work in the background. So this is what I started with, then the modification happened in this part. This is the complete assembly, and these are the modified part which I designed as an adapter with existing Arduino buggy, where you can see it can clamp the motor, and it has got new adapter for Omni wheel. So if I can explain that this Omni wheel has got different diameter than the shaft of this TT motor. That's why I have designed them from the scratch. So in total, three part I have designed. One of this motor clamp, and then the motor shaft and the base plate for connecting with the Arduino buggy. Now, if I can show you the Fusion 360 part, so this is the base plate where this 2 plus is actually slotted to the Arduino buggy plus shaped blank. Now I will include the complete file, and you will also see the operation of the real life robot. Here you can see the operation of real life robot. Hopefully you like this video. Let me know your experience with this video at the comment box, and feel free to ask me the VIDA file as well as the Fusion 360 file. I will see you at next time. Till then, thank you very much.